But let's take a look at angle pair relationships. And in general, drawing a diagram is helpful, but let's just talk through some of these angles before we get to that point. The first one is adjacent angles. There are two angles in the same plane that have a common vertex and a common side, but no common interior points. Maybe what's most important to you to make sense of it all is that angles need to be next to each other. They're side by side. That's maybe a better way. So do you need to write that in your notes? They're side by side. Up to you. Vertical angles. Vertical angles, I like to think of it as they form an X. But these are not side by side. So two non-adjacent angles, they're formed by two intersecting lines, and then the angles are across from each other. So, as I illustrate this angle here is the same as this angle there. Let's try that again. This angle here and this angle here are vertical angles. They're across from each other in these intersecting lines. These two angles in red are also vertical angles. Complementary angles. Two angles whose measure sums to be 90 degrees. Sum. Sum means add. So if you don't know that, it's add. And supplementary angles are two angles whose measures sum to be 180. Again, sum is add. Linear pair is a pair of adjacent angles. So they have to be side by side. And they also have to be supplementary. Supplementary adds to be 180 degrees. And in fact, what happens is it's a pair of angles that make a line. And if you look at the box underneath this, there's a picture of linear pairs. And it's a theorem. It is something that we can prove. But this is an illustration of a linear pair. So here's an angle, angle A, and angle B. They are side by side. They share, or they don't. Ugh. And then we've got this ray in between them. And they add up to be 180 degrees. And oftentimes what I like to do is I like to draw a protractor to show that something combines to be 180 degrees. And that's what it says under here. It says, if two angles are side by side, then they are supplementary. And what we can say is the measure of angle A, so here's angle A, and the measure of angle B, that didn't work, A and B combine to be 180 degrees. Oh, no. So, we take a look at our example here. We've got angle KPL and angle LP, angle JPL are a linear pair. And the nice part on this one is that it's already labeled for us. We don't even have to label. It's drawn for us. It's labeled. Linear pairs, again, are side by side. So KPL is beside JPL. And what we know about linear pairs is that these add to 180 degrees. So if we know the definition of linear pair, that can be helpful when setting up the problem algebraically. Because we want to find the measure of angle, or we want to find x, and then we want to find the measure of angle KPL. So we're going to take this value of 2x plus 24, and we're going to add it to our adjacent angle of 4x plus 36, the angle right beside it. And when we add those two angles together, we end up with 180 degrees. Combine like terms. 2x plus 4x is 6x. 24 plus 36. Again, if you don't know what that adds to be, use Desmos. But I believe it adds to be 60. And then we can solve this equation. So we're going to move the 60 to the other side. And then we end up with 6x equals 120. And finally, 6 times x, we need to undo the multiplication. So we're going to divide both sides by 6. So we end up with x equals 20. However, that's not the only thing that we're looking for. We have to find x, but we also have to find angle KPL. KPL is, so the measure of angle KPL is 2x plus 24. We're going to take this value of 20 that we just found, I'm going to put it in here for x. So I'm going to put that in here. So this is 2 times 20 plus 24. And then 2 times 20 is 40 plus 24. So the measure of angle KPL equals 64. Use a diagram to name a pair of angles that satisfy each condition. So now we get to a diagram here where we can identify vertical angles and supplementary angles and all of those kinds of angles. Again, vertical angles are right across from each other. So it says name a pair of vertical angles. Well, the fact that this is 65, let me circle it so people can see that on the video. This is 65, and this is 65, and they are across from each other. Means that those two angles are vertical. I'm going to erase that just so I can see the proper letter here. But we can say that angle VZY and angle XZW are vertical. Again, that's the 65 here and the 65 here. So there's two vertical angles. If you look real close on this angle here, which is VZX, and VZX, let me see if I can do better there. Still a little bit of smartboard issue. Is the same amount as YZW. 65 plus 50 does add to be 115 degrees. So here and here with the 65s, that was the obvious answer, but the 115 degrees along with the combination of 50 and 65 is a not so obvious vertical angle. Vertical angles are across from each other. Typically, you start with an X, and it does kind of look like an X with an extra ray in there. If we look at adjacent angles, again, the thing is that Elena could say one answer, and Brady could say a different answer, and they're both right. There's more than one set of adjacent angles, but they are side by side here. So let's stick with our 50 and our 65 here. If we say angle YZT as well as angle TZW, remember that the vertex needs to be that middle point. YZT, the vertex of that, and then TZW. Z is the vertex of both of those. So finally, on this particular problem, for linear pairs, two angles that form a linear pair, they have to be side by side, and they also have to add to be 180. And again, that's where you can draw the protractor, and maybe that'll help a little bit. So if we draw the protractor, I'm going to draw it right there. Not our only option, but there's a protractor, and once we can identify the protractor, then we can do this problem here. We can identify two angles that are linear pairs. YZV and VZX. Not the only option in that picture. That's just the one I particularly saw. If I just identify another one, I won't write down the answers here, but what about right here? Maybe that's what you saw. So there's another place where you've got a linear pair, but it's two. So you need to break it apart into two that are side by side and combined to be 180 degrees. So if we flip over here to the back, another important angle theorem is the vertical angle theorem. And when we finish with this problem here, it says if two angles are vertical. So if you can identify that something is vertical, that means that they're congruent. And then when we look at the measures of those angles are equal. So when we look at an example here, it says use the figure to the right. Measure of angle 2 is 5x minus 7. Again, I can recommend that you label. Measure of angle 4 is 12x minus 42. And what we see about these two angles is that they are directly across from each other. If you look at this, they do form an X, and consequently, because of that, we can identify the fact that they are vertical angles. And once we know that they are vertical angles, what we're going to do is we're going to take 12x minus 42, and we're going to set it equal to 5x minus 7. And now that we know this, I'm going to move my letter to the left. You solve it the way your Algebra 1 teacher taught you. In this case, that's probably how your Algebra 1 teacher taught you. Subtract 5x from both sides. 12x minus 5x is 7x minus 42 equals negative 7. Again, if you don't know what 12 minus 5 is, or maybe you do, but you're afraid that you're going to do it wrong, type it into Desmos. Then, we're going to move the 42 over here. So we're going to add 42 to both sides. And we end up with 7x equals, well, 42 minus 7. And all of a sudden I'm having a lapse, but 12 minus 7 is 5. 35. Finally, we want to know what x is in this particular case, and that's all that's asking for. But 7 times x, we're going to divide both sides by 7, and x equals 5.